Session 11.2 Regression Equation. From last sessions, we're verifying that the linear correlation between two variables is significant. Next step is to determine the equation of the line that best models the data. This line is called a regression line, and its equation can be used to predict the value of y for a given value of the x. Let's look at this scatter plot. All the sample data is going to be going on this direction, and we know the slope is going to be positive. And we say if we could draw the straight line in here, and all the points is going to be around the straight line, we believe there is positive linear correlation between these two variables. And for these sessions, we'll be study for this straight line, and we call regression equation or regression line. The regression equation writes like this way: y hat equal to b naught plus b1x. Do you guys still remember you learned the linear equation in the algebra class? At that time, we have the equation y equal to b plus mx. Remember that? And then b, that is represent your y-intercept. Y-intercept, talking about your linear equation is going to be intercept the y-axis. Okay, so b will be the y-intercept. And then plus mx, the m here talking about the slope of this linear equation. For this example, that will be the increasing. So we know the slope is going to be positive. Okay, so this is the linear equation we learned it from the algebra class. And for these sessions, the regression equation, we write it like this way: y hat equal to b naught plus b1x. And then when you compare with these two equations, b naught, that is represent your y-intercept. Okay, b naught, that will be your y-intercept. And then the b1, that will be represent the slope of this equation. Okay, how about the x and the y hat? X we call the explanatory variable, or you can call this as a predictor variable or independent variable. And then y hat, this is called the response variable or dependent variable. And the regression equation can be used to predict the value of y. Since y is a dependent variable, always given the value of x, and then we're going to find out what is the predict value of y here. Okay, look at this example. We do have the scatter plot shows a negative linear trend. And the variable of x, this is talking about the age of car. And then the y variable, this is talking about the price of this used car. So you're gonna see we do have the negative slope. Means the age of the car is increasing, then the price of this car will be decreasing. We do have the regression equation here. So they're gonna write it down. The regression equation will be predict value, which is gonna be your y hat equal to 21,375 minus 1,215 and then times the age. And one more time, this is represent your y-intercept. Okay, so you can see if I extend this line, cutting in here, and this number, that will be your y-intercept, which is going to be 21,375. And then negative 1,215. This is talking about the slope. When your slope is negative, means it's going to be decreasing. Okay, so let's try to rewrite this equation. That will be y equal to 21,375 minus 1,215x. Okay, now I want you guys use the regression equation to predict the value of car that is 12 years old. means the age of this class is equal to 12, and I want you guys find out the dependent variable of y. How much of this class now? So what we're gonna do, we're gonna plug it in. Plug in x equal to 12. Use your calculator. You should get y equal to $6,795. Requirement will be same as the last sessions. Simple random sample, and then we need to do visual examination of the scatter plot. Make sure they do have the strychnine pattern. And also look at the scatter plot to see if there is an outlier. If there is outlier, make sure you remove it before you finding the regression equation. We do have a two set of the formula for the regression equation. Okay, the B0 and then the B1. Okay, so you're gonna plug in the variable of x to your L1, plug in to your y variable to your L2. Okay, use your TI-84 calculator. Figure out all the summation x and summation y here. Plug it in, and then you figure out what is your B0 and B1. Or you could strictly using your calculator. So follow the procedure of session 11.1. Okay, or look at this instruction here. Now, let's do the example together. Small company has 5 employees. Following table presents the number of the years each has been employed and the hourly wage in dollars. A. Use the calculator to find the regression equation. Okay, let's do it together. Okay, let's plug in the data. Okay, double check. Your x will be on your L1, y will be on your L2. Okay, follow the same instruction from the previous session. Go to the stat, go to the test, go up to find the linear regression t-test. Enter. My data is gonna be on L1 and then L2. Choose not equal to. For the regression equation, we're gonna click on vars, go to y vars, choose number 1 function, and then there should be nothing in here, okay? And then we're gonna choose y1. Go calculate. Enter. So you're gonna see I do have the regression equation y equal to a plus bx. Okay, y equal to a plus bx. So my a, that will be 7.7799. My b, that will be 1.7417. Okay, 1 to 2 decimal space. So a will be 7.78, b will be 1.74. Okay, what has the regression equation? Y hat equal to a plus bx. Construct a scatter plot with a regression equation. So I will strictly copy from my calculator. Do the same thing. Go to second, step plot, enter for the first one. Turn it on. Choose the first icon. And then go to the mark, click on the zoom, number 9, zoom step. Okay, copy this screen here. Make sure when you construct the scatter plot, that is with the regression equation. Okay, for your scatter plot, make sure including the title, label the x-axis and label the y-axis. Now, see, Use the regression equation found in Part A to predict the hourly wage in dollars for an employee who has been employed for 4 years. Interpret the result in context. So now we're gonna plug in x equal to 4. Find out what is your predict value of y. Okay? Plug it in, x equal to 4. Use your calculator. You should get 14.74. Okay, and then interpret the result. I'm gonna say, if an employee has worked for 4 years, the predict hourly wage will be $14.75. Okay, example 3. I want you guys try. Input the data on your L1 and then the L2. Okay, click on the stat, go to the test, go up, find the linear regression t-test. Make sure you do have the y1 for the regression equation. Let me do it one more time. Go to the VAS, y-VAS, choose number 1 function, choose number 1, the y1, and then go to calculate. So you do have regression equation, y equal to a plus bx. They given the a and then the b here. Okay, 1 to 2 decimal space. So write it down. Regression equation equal to y hat equal to 11.04 plus 0.82x. And then get the scatter port, so go to second stat port, turn on the first one. Choose the first icon. My data, x will be on L1, y will be on L2. Okay? And then click on the zoom. Number 9, zoom stat. You're gonna see this picture. Okay, copy this picture. One more time, make sure you write down the title, label the x-axis, and label the y-axis. Okay, C. Use the regression equation from Part A to predict the percentage of 8th grade students who are proficient in mathematics when the percentage proficient in reading is 80%. Interpret the result. So the given x is gonna be 80%. Find out what is the predict value of y. Plug in x equal to 80. So y equal to 76.64. Interpret the result. If a state has 80% of 8th graders proficient in reading, the predict percentage proficient in mathematics is about 76.8%. Okay, cautionary notes regarding the regression. Don't use linear model to describe nonlinear association. Always look at the scatter plot first. So every time when we're finding the R and the regression equation, we have to look at the scatter plot. Make sure they do have the straight line pattern. If there's a no straight line pattern, we cannot use the regression equation to find the predict value. Correlation is not causation, and association between two variables is not sufficient evidence to conclude that a cause and effect relationship exists between the variables. We talked about this already, right? We only can prove these two variables is associated with each other, but we cannot draw the conclusion saying one thing caused and other things to happen. Beware of outliers that can have a big effect on all. Always check the scatter plot for outlier first. Okay, we keep saying that if there is an outlier, we have to remove it before we finding the R. Don't extrapolate. Don't make predictions beyond the range of the data because we are not sure that the linear trend will continue beyond the range of the data. When we use the regression equation to find the predict value of y, make sure your value of x will be within the range. If the x is far away from the majority, then we cannot use this x to find the predict value of y. Let's look at this example. In a previous example, we found there was a strong linear relationship between the height and the weight in women, and the regression equation is, I have the regression equation, weight equal to negative 442.882 plus 9.03 height. What height does this equation predict for a woman who is 36 inches tall? So now you could see x is equal to 36 and I want to find the predict value of y. Let's try to use this regression equation. So we're gonna plug in x equal to 36. Use your calculator. You're gonna find that your weight is gonna be negative 117.8 pounds. Is it possible? No, right? Weight cannot be negative. Why? Because the range of the data for the woman, that is only from 61 to 68. And 36, that is outside of this range. So it is not appropriate to use the regression equation to predict the height of a 36-inch tall woman. And we call this is gonna be extrapolation. Okay, keep in mind the x has to be within this range or really close to this range. Interpreting the slope of the regression equation. Slope tells us how much the y variable changes when the x variable is increased by 1 unit. And the slope close to 0 means there is no linear relationship between x and y. So think about it. The regression equation is going to be y hat equal to b naught plus b1x. So if b1, the slope equal to 0, that means y hat, that will be equal to y-intercept, right? So that means this is no linear relationship. When you interpret the y-intercept of the regression equation, the y-intercept is the predict value when x is equal to 0. When x is equal to 0, the b naught, that will be the y-intercept, which is going to be equal to the predict value. And the y-intercept is meaningful only if it makes sense for x equal to 0. Okay, it really depends on your question. Sometimes when you plug in x equal to 0, the y-intercept is meaningless. Okay? Okay, example 5. Interpreting the slope and the y-intercept. We have the regression equation. The y represents your weight equal to negative 442.88 plus 9.03x. And then the x, that is represent the height. Interpret the slope of the regression equation. Interpretation. So you can see for every additional inch in the height, when you add 1 unit on the x in here, so y will be increasing 9.03 pounds in here. Okay? So another way to say, every increase of 1 inch in height is associated with an increase in the weight of 9.03 pounds. Okay, this is how you guys interpret the slope. Now, interpret the y-intercept of the equation. So, when we interpret the y-intercept, talking about the x is gonna be equal to 0. When x equal to 0, the y, that will be equal to negative 442.88. And think about it, it is impossible that the weight is gonna be negative. And also, it is impossible for the woman to be 0 inch tall. So this case, y-intercept is meaningless. Okay, example 6. Figure below shows the relationship between the age and caliber book value for a sample of cars. Regression equation is gonna be this. And the y variable is the value, and the x variable is going to be the age of the car. Interpret the slope of the regression equation. So we're going to say for each additional year of the age, the value of the car will be decreasing. Okay, will be decreased by 1,215 because the slope is going to be negative. So we're gonna say each additional year of age is associated with a decrease of 1,215 in value. Now, let's look at the y-intercept. Is it possible that x equal to 0? X is talking about the age of the car, right? So when x equal to 0, talking about this car will be the new car. So when x equal to 0, y will be equal to 21,375. And this makes sense, right? Because when the car is new, its value is going to be $21,375. Okay, coefficient of determination. We call that a R square. Coefficient of determination denoted as R square. It's a statistical measure that indicates how well the regression model explains the variability of the dependent variable based on the independent variable x. So how can you find the coefficient of determination? R square. So we just need to find out what is your R and then take square. That will be the coefficient of determination. And then usually convert to a percentage. So always between 0% to 100%. When R squared is close to 0%, indicate a model with very little explanatory power. But when your R squared is going to be close to 100%, that indicates the model with very much explanatory power. Okay, let's try on this example. A researcher studies the relationship between hours study and exam score for 10 students. After performing linear regression, the equation is y hat equal to 50 plus 5x. Correlation coefficient R equal to 0.9. Find and interpret the coefficient of determination. So first, R equal to 0.9. This is going to be positive and strong linear correlation, right? Positive and close to 1, so strong linear correlation. And then we do have the regression equation here. So first, R equal to 0.9, and then we want to take square, find out the coefficient of determination. So take square, that will be equal to 60.81. And we try to write it as a percentage. So R squared equal to 81%. Okay, so how we interpret the coefficient of determination. 81% of the variation in exam score can be explained by the number of hours study. Okay, so we do have 81% of the exam score. That is because of the number of hours studies. And then the remaining, use 100 minus 81%. The remaining 90% is due to other factors, like the test anxiety, prior knowledge. Okay, example 6. For the data on car age and predict value, R equal to negative 0.77x. Compute and interpret the R square. So just take square of the R. You're gonna get 0.605. Convert it to the percentage. That will be 60.5%. And this is talking about the age of the car and also the price of the car. Right? So we're gonna say 60.5% of the variation in the car's predict value can be explained by its age. So other factor, that will be something else. That's it.